So, can I start? Or the students are still coming? Share this message with your student that soon I will take the snapshots of the attendance. So it is better. It is better
Okay,
to
sir.
attend this last session.
सर आ रहे हैं अभी.
Okay. Because I have to keep this in my mind that because I have to take the attendance. If I will forget, then it is just it is a request to you all students that just remind me at the end that you have to take the attendance actually, so that I can
Okay,
take.
sir.
Hmm. So let's start, and this is the second slide. We are discussing that how this genetic algorithm can be terminated, and we have seen that when solution is found, this is one option, or we said that it can be the designer criteria, or it can be left over the population to find their solution by themselves. But you will see some another option of for the termination of your algorithm here on this slide. So this point is saying as a whole something that sometimes it happens that you don't have the optimal solutions available in your population, and if this is the scene that you don't have your optimal or global maximum available in your population, I'm using different terms to give you an idea that what it means. So uh, if in my if in my population, uh, if the maximum member who has the fitness value maybe 70, if this is my maximum fitness value in my population, that is, for example, suppose it is 70, and if I am trying to get uh, uh, optimal solution, which is a member with the fitness value 80, but in my population I don't have that member, or in my population the maximum fitness value of a member that I have is 70, I don't have any member with 80 value. So what will happen then? So my genetic algorithm will iterate again and again, iterate again and again. It will iterate again and again, and but it will remain fail all the time. It will not reach at the 80% because I don't have a person in my population with fitness value 80%. So what you can do now? So you this is something very much definite that you are not going to get your solution. So in this situation, you have to rely on the suboptimal solution. You don't have to search the optimal solution now because that optimal solution is not lying in your population. So in this situation, what you have to do, you have to rely on the suboptimal solution, the maximum solution that is available in your population, and that is 70%. And that is not my global maximum, but it is my local maximum. I hope you are understanding my these terms, because you already have the concept of global maximum and local maximum. So my global maximum is a person with 80% value, but now this local maximum is a person with 70% value. So I have to rely on the suboptimal solution, and because I don't have the global maximum in my population. So this is one thing I have to rely on the suboptimal solution. How can you can find this situation that uh, now my okay, when you are, before discussing this, when you are finding your suboptimal solution, what it means actually, if you are relying with your suboptimal solution, what actually its meaning. So the meaning is that your population is not remained too much diverse now. So this is the conclusion. Now I will explain. I said I want to find a member with 80% percent value, but I don't have that member mm, in my population, which means that now my population is not diverse. This is something you maybe you will accept, because I already explained diversity in previous slide. So if I am not getting my global maximum, if I am not getting the person with 80% value, which is the global maximum, then it means that my population is not remained diverse now. So diversity is vanished in my population. And when your population is not remained diverse, then how you can detect this situation, how you can detect this situation. I know that when my population is not remain diverse, then it means that most of the people in my population are similar. That's why it is not diverse. Diverse mean different people with different value. But if my population is not diverse, then it means that most of the members in my population have the similar value, fitness value. And if this is the situation, that I have to terminate my algorithm, because I will not get global maximum, I will not get better solutions. So if my all members in my population are very much similar to each other, then this is not a good situation, and I have to terminate my algorithm. But how can I identify? But the question is, how can I detect that my population is now very much similar to each other? So it is very easy to find. You have to calculate here. I am just highlighting it with cursor, that you have to calculate the average fitness of the population. In your population, you have the members, and for your members, you have the fitness values. You have to sum up all the values, and then you have to divide the sum with the total number of the members available in your population. Then what you will get? You will get average. So that is the average fitness of the population. Now keep this average value at one side, and now find in your population the member with the maximum fitness. Find that member, and if that member is, suppose if that member is for example 70, then now you have to compare this maximum fitness value of this member with the average fitness value. And if your average and maximum value are very much close to each other, then it means that most of the members in your population have the similar value. Are you understanding?
Yes, sir.
Yes, sir.
Okay. So uh, if your average is very much close to your maximum value of the member in your population, this means that most of the member in your population are very much similar, to each other in terms of fitness value. And this is the situation that you have to terminate your algorithm. So this was the fourth uh, termination condition, according to our discussion. Three were discussed here: solution, designer criteria, population, and this is the fourth one. And I already discussed global maximum and local maximum here. So this point is already covered. This is this last point is the same point as you discussed here on the slide, but written in terms of global and local maximum and global maximum terms that you already understood in the beginning of the session about local and maximum searches. So this is the algorithm. We can go through this algorithm, but in the next section we will start from here with this example. But up to now we can get an understanding of this algorithm. But in the next session or in the next class we will run this example on this algorithm, and that will also take time. So for the time being, we are going to see this algorithm only in this class. So this is genetic algorithm, and it normally takes a population, and now you have the understanding of population. And the other thing it will take is the fitness function. This is the function that you have to give to this genetic algorithm, and through this function it will calculate the fitness values of the different members of lying in your population. And this algorithm returns an individual simply. The inputs are the same, population and the fitness, and I have explained what population is and what fitness function is. This is already mentioned here. And so we have a repeat until loop here. And I can make my annotation again active so that it will help me. So this, we have a repeat until loop here, and this is your old population, and we have a new variable here, new population, and this new population is empty at the moment. But this population that we are taking as an input in this algorithm, this is not empty. This is full of members. This is full of individuals. So, but this is a new variable, new population for the new members that we will get. This is for those for that purpose, and initially it is empty. And then we have a for loop. कोई क्वेश्चन हो तो पूछ लिया करें बीच में. मेरी आवाज आ रही है?
Yes, sir, आ रही है.
चलें ठीक. So now we have a for loop here, and this for loop is from I is equal to 1 to the size of the population. Suppose if you have just a minute, I have to make something disable so that अभी एक बच्चा जो है ना वो एनोटेशन टूल्स को यूज कर रहा था, लेकिन मैं अगर डिसेबल ही कर दूं तो बेहतर है. ऐसे मेरा टाइम जाया करेंगे. अच्छा, so this is the for loop from I is equal to 1 to size of the population, and if the size of the population is, for example, 10, then this loop will, members in your population is 10, so then this loop will run through from 1 to 10. And what you will do, the next step is random selection. I will select something randomly from the population by using some fitness function. So here it is, you are mentioning fitness function and then selecting randomly. So fitness function is only to calculate the fitness value. It can be square, it can be cube, it can be any other question, Euclidean distance or anything. It depends on your problem actually. It depends on your problem, and then you can select any fitness measure according to the nature of your problem. So in your population, you have to select some parent randomly. You have to select some parent randomly by using this fitness function. So for example, if I have 10 members, first I have to apply the fitness function, and then I will calculate the fitness value. This is a function that you have to call, but not mentioned here. But the purpose of this function is very much easy to understand. that from the population, this fitness function will calculate the fitness of all the members. And then this random selection will simply, if it is a latest method, you can select top 50%. Okay. And then you can select randomly from those top 50%. Are you understanding? People are silent. What is the reason? I am explaining that in random selection, you have the population, maybe it is 10 members. You can apply any fitness function and you can calculate the fitness value of those members first. And then you can apply the latest method. And by using a latest method, you are now getting top 50% members from your population, and it is 5. And from those 5, now you can select randomly any member. And that randomly will go into this variable x. So you can select any member randomly, and that will go into x. And similarly, you can do the same thing again to get another member as y. So now you are getting x and y through selection methods, and selection is your step number 2. And now your selection is your step number 3 in the diagram that we already have seen. And the final step is step 4, which is the recombination, and it is renamed here as reproduced. So this is recombination. So we have 2 members selected from the pool, x and y. So we have a function reproduce or recombination, and this is reproduce is mentioned here. And these 2 members are going as an input to this reproduce. Now the control will come here at this function. And this function is again returning an individual, but let's see what will xi. We know x and y. We know that this is the parents that we have randomly selected. So first you have to compute the length of this parent x, and I can yes, maybe if my annotation is working, just look at. So for example, I can write some string here, or I can just, it is better to write on the whiteboard, because on the whiteboard we can do the things easily. So I am stopped. Are you hearing my video?
Yes,
are
sir.
you simply?
Yes, sir.
Sorry, are you seeing my video, or you are seeing only the slide, this algorithm?
सर आपकी वीडियो भी नजर आ रही है, एल्गोरिदम भी आ रहा है.
अच्छा, चलो ठीक है, ये दोनों चीजें नजर आनी चाहिए असली. ये मुझे नहीं नजर आ रहा, इसलिए मैं आपसे पूछ रहा हूँ, क्योंकि मुझे यहाँ पे अपने कंप्यूटर पे नजर नहीं आ रहा. तो मेरा ये बोर्ड नजर आ रहा है आपको पूरा?
यस सर.
पूरा नजर आ रहा है?
Yes, sir.
Okay, then I can continue.
Yes, sir.
So for example, here on this slide on which the algorithm is mentioned, so we are computing the length of the parent, and parent is x. Suppose I have 2 strings. One is, for example, Ali, and the other is, we can take, okay, simply Cash. Nothing is coming into my mind, so I have just simply taken these lengths. So I have to calculate the length of, so this is my x and this is my y. So this is very much simple. So length of x is 3, and that 3 will go on to this variable n. So now this n has the 3 value, okay? And then I have to random number from 1 to n. So from 1 to this number n, I have 1, 2, 3. So I have to generate some random number which I will store in this C. So okay, suppose this number is 2. This random number is 2 that I have stored in C in the algorithm. Now, this is the last statement. Append, and then we have substring, one substring, comma, another substring. So we have now we are combining or appending two strings according to the crossover operation that we have. We normally mark something in the chromosomes and then we will swap the tails of those chromosomes. This is the concept of the crossover operation. So suppose this is now your point that you have marked. From 1 to 3, you are getting 2. So this is your C for crossover point. This is your point actually. So append substring X. So now dealing first with the X string, which is this one. And from 1 to C. And C is what? C, value of C is 2. So from 1 to 2, the value of C is 2. From 1 to 2, I have to get the substring. From 1 to 2. So this is 1, 2, 3. So this is the substring which is al. This I am getting here in this portion of the algorithm. And again here, we are now considering the other string, which is y, this one. And it is going from C plus 1. C is what? 2. So 2 plus 1 is 3. So from 3 to, what is the value of n? 3. From 3 to 3. So this is 1, 2, 3. This is 1, 2, 3. So this is from 3 to 3. Only y. So I will get only s. So I will get only s. My complete whiteboard is in view of yours, all students?
Yes, sir.
Okay. So this is something, the first substring, and this is something, the second substring that you are getting here. And now there is a function append, which will append these two strings. And what I will get? ALS. What I will get? ALS. So this is the new string in the algorithm. Now we can focus on the algorithm. Now we can focus on the algorithm. And now I can stop my video. So in the algorithm, this reproduce function will give us the string according to my whiteboard analysis ALS to this child. So ALS will come here in this child. And here, this is something we are checking. If we are checking some kind of a probability, and if that probability holds, then we are applying some kind of mutation operation. This is the operation that I discussed here, but leave it for the moment because we are just running it initially. This statement, anyhow, we can explain it. Here you have to write the range of the probability. It could be from 0.8 to 1 or 0.5 to 1. It is up to you. You have to write the range of your probability. And that probability could be totally separate from this child, or that probability you can compute from the bits of the child that you have here. So we will see how you can, we will see, for example, in upcoming slides, in upcoming slides, the slides are locked. I am trying to change the slide, but slides are not changing. Okay. Here on this slide, I will give you this concept that how you can compute the probability. I will give you this concept, but for the moment, for that time, just take it as it is, as I am giving actually. So if the probability of the child that you have here is approaching to some limit that you want to mention here, that you want to evaluate here, or that you want to hold. And if that condition becomes true, then you can apply the mutation operation over the child. And the mutation is very simple. You have to change one bit and any position in the child. So this is now, this statement is now clear. Only this portion is remaining, that I will explain when I will reach on that slide. So now to the next. So I am now getting this child, and in the next statement, I am adding this child to the new population. This is the variable new population, and here I am adding this child to the new population. And now this is the end of the for loop. All these statements are under this for loop. This statement is not under this for loop. This statement is under this repeat loop. So, okay, add this child to the new population. So now the child is added, and then I can go again to this for loop. Now I will become 2. If size is 10, now I will become 2, and then I will again select something randomly, 2 parents, and then reproduction again. And then I will get child, I will check the probability, and then I will add that child again to new population. And in this way, this for loop will execute for 10 times if the size of the population is 10. Anyhow, I hope that you understood all the statements here under this for loop. When your for loop will terminate, then the next step is, then you are updating or upgrading this new population into your old population that you have. Now in your population, you have the new population. And now this is the end of the repeat loop, but there is some condition that you have to check. And if that condition will fulfill, then we can either continue or discontinue. It is basing on this condition. So this is the repeat, and this is until. So this is the repeat until loop. And the condition is some individual is fit enough or enough time has elapsed. So here, if it is a do while or if it is a repeat until loop, then this is the condition of that loop. You can fix some time for this genetic algorithm. For example, you can fix 2 hours, and then this genetic algorithm will run for 2 hours. Or you can set some condition for the fitness of some member, that maybe, for example, you can write here some condition that if the fitness value of a member is equal to 80%, then you can quit. So you can write something, some condition on the fitness of some member here, or you can write the condition on time here, or any other criteria. You have to, this is basically your termination condition of the genetic algorithm. And all the possibilities that we have seen here, in previous slides, you have to consider those possibilities here. And after that, now if the condition will hold, you will get out of this repeat until loop. And this is the return statement, the best individual in the population according to the fitness function. If you have calculated if you have, for example, if the time that you have fixed is elapsed, or the condition on fitness you have checked here in until, here you, after that you have that member in your population. For example, the fit member, or after 2 hours you can check that which member is the more fit, and then you can return. So you can simply return that fit member. You can simply return that fit member here from the population according to the fitness member function that you have already calculated. So this is the end of the algorithm, and I will continue inshallah in next class from this example. This is again a lengthy example, and then we will see what will happen with us. So this is the end, and now I am going to take the attendance, and then I will ask you something, or I will give you the chance to ask something. Because I have
एक्सक्यूज मी सर
जी
सर वो टर्म पेपर के बारे में सर कुछ गाइड करते हैं या
हाँ
अगर
वो
पॉसिबल है
हाँ ये करता हूँ मैं, जरा थोड़ा सा ना स्नैपशॉट्स ले लूँ 2-3 तेजी से। ये मैं इसकी रिकॉर्डिंग भी रोक दूँ, बहुत होगी रिकॉर्डिंग। रिकॉर्डिंग हो भी रही है, नहीं हो रही मेरे ख्याल?
सर हो रही है सर।
हो रही है, मुझे मैसेज नहीं नजर आया, किधर गया? स्टॉप